Hey everyone, welcome back to LearningHub, where we make the math behind machine learning crystal clear and actually fun. So, we're continuing our Math for Machine Learning series, and in this part, we're diving deep into the world of linear algebra, the true language of machine learning. Today, we'll explore how matrices and vectors interact, starting with basic operations like matrix addition, scalar multiplication, and transpose. Then, we'll uncover the magic of the dot product and what it really means geometrically. And finally, we'll connect it all together with matrix multiplication, one of the most powerful tools in ML. So, let's begin. Let's start with something simple yet super important, matrix addition. Matrix addition works element by element. If two matrices A and B are of same size, you just add the corresponding element as shown in the example here. It is that straightforward. Now, what about scalar multiplication? That's when you multiply every element of a matrix by a single scalar number, or basically by a scalar. So if you take matrix A and multiply it by this particular scalar constant 3, you'll just scale all of its value by 3. This is how we stretch or shrink a matrix. And finally, we move on to the transpose, written as AT. The transpose basically flips a matrix over its diagonal. Row becomes columns and column becomes rows here. You can see that in the example here too. So basically in the field of machine learning, the transpose is used all the time, especially when we want to align dimension for operations like matrix multiplication or when working with our feature vectors. Now let's talk about something deeper, that is the dot product. So if you have two vectors A and B, the dot product of A and B is the sum of the element wise multiplication of its individual elements here. So the dot product of A and B is A1 B1 plus A2 B2 plus and at last A and Bn. So if we refer to it algebraically, it's just the sum of element wise multiplication. But geometrically, this is where things actually gets very interesting. The dot product also equals the magnitude of A multiplied by the magnitude of B times cos theta, where with the magnitude of A, or this particular symbol represents the magnitude of vector A, this particular symbol here represents the magnitude of vector B, and theta represents the angle between these two vectors here. This means that if these two vectors point in the same direction, then the cosine is 1, which means the dot product is positive and large. If they are perpendicular to each other, then the cosine value is 0, which means the dot product is 0. And if these two vectors are in the opposite direction, then the cosine is minus 1, which means the dot product is negative. So this geometric view is super important in ML because it tells how aligned or similar two vectors are. In fact, when you want to measure the similarity between word embeddings or feature vectors, you're often using the cosine of the angle, which directly comes from the dot product here. Now let's bring everything together with matrix multiplication, which is the true workhorse of modern machine learning. So matrix multiplication is not element wise. Instead, it's based on taking the dot product of rows and columns. So if A is a matrix of size m into n and B is of size n into p, you can multiply them only if the number of columns of A is equal to the number of rows in B. That will result to a new matrix of size m into p here. So what it means is each element of the result, which is basically represented here by Cij is equals to the row I of matrix A times the column J of matrix B. Let's see in this particular example here. Now in this example we can see that C11 is equal to the row 1 of column A, row 1 of matrix A as well as column 1 of matrix B plus row 1 of matrix A as well as row 2 of matrix A as well as column 2 of matrix B, and so on. And then we can obtain our resulting matrix C as shown in the example here. And there it is, every value formed in the matrix C is formed from a dot product between the row and column. So why are we learning all of this? We're learning all of this because these operations, addition, scalar multiplication, transpose, dot product, and matrix multiplication, are the building blocks of every machine learning algorithm. From simple linear regression to deep neural networks, they all rely on these same linear algebra foundations. So when we write y equals x times b, that's matrix multiplication, which means each output in y is a dot product between one data point's features and the model's weight. And that's exactly how your machine learning model is going to make your prediction. So that's it for today's episode of Learning Hub. We've learned how matrices interact, how vectors form angles, and how all this math powers modern machine learning. So in the next video, we'll continue this maths for machine learning journey, exploring some new topics here. So don't forget to like, share, and subscribe to Learning Hub, where we make learning math for AI more simple, meaningful, and fun.